In every internal combustion engine, be it in a car, truck, ship, or generator, operating at the ideal fuel-to-air ratio is crucial to optimized combustion efficiency. As part of the combustion cycle, the engine generates a vacuum, sucking the air needed for combustion through an air filter from the atmosphere to the combustion chamber. The air filter is designed to catch dust particles and other impurities that may damage the engine. However, along with the oxygen used in combustion, nitrogen, humidity, and other trace gases in the air are also drawn into the combustion chamber, complicating the combustion process. The combustion that follows is far from ideal. To achieve complete combustion and better fuel consumption, the engine is constantly fighting to increase the air-fuel ratio. However, this also increases harmful NOx emissions, a byproduct of combustion from the reaction of nitrogen in the air. When excessive NOx is detected by sensors, the engine must enrich the air-fuel mixture, compromising the conditions for complete combustion and optimal fuel economy. Compounding the problem, both gasoline and diesel engines achieve highest thermal efficiency when operated with a high load in the mid-RPM range. Ironically, though running an engine at low RPM and light load uses the least amount of fuel as it has less work to do, thermal efficiency is not that high. Humidity or naturally occurring water particles, H2O, also in the incoming air, pass harmlessly through combustion. However, they steal some thermal energy generated by combustion as they are emitted out the exhaust. Over time, incomplete combustion can also result in a buildup of carbon deposits left over from unburnt fuel that, over the life cycle of the engine, increase internal friction and can also interfere with the fuel combustion process. The net result is that in the real-world environment, internal combustion engines rarely operate at the optimal conditions that extract the highest thermal efficiency from the fuel, compromising fuel economy. In an engine using NANOEFX, the air filter transforms into an electric field. Using a phenomenon known as the piezoelectric effect, some of the air molecules passing through the air filter will hit the active ingredients in NANOEFX, and the energy from bombardment is converted into electrical charge. As the water molecules from air humidity pass through the electrical field, they pick up charge and become ionized. That is, H2O particles split to become H2+ ions and OH radicals. Together with the incoming oxygen, the ionized particles then become active participants in promoting the chemistry for complete combustion and reduce the unwanted byproducts of incomplete combustion known as emissions. Even a slight reduction in emissions can have a big effect over time. Less NOx emissions means greater opportunity for the engine to achieve fuel-efficient lean burn conditions without exceeding NOx thresholds. The benefit of NANOEFX is even greater when the engine is operating in the range where thermal efficiency is low. In addition to the engine running cleaner, reduced emission using NANOEFX may have an added benefit on modern diesel engines. Fleet customers are also reporting reduced load and extended service life on exhaust gas recirculation and diesel particle filter systems used to manage carbon soot particles in the exhaust as a side benefit from using NANOEFX. NANOEFX also includes a unique blend of natural products originally used in the healthcare industry. Once applied on the air filter, trace amounts of these products are slowly released into the combustion chamber, where they act as a lubricant gel to help dislodge any carbon sludge deposits. From the introduction of the first fuel additives in 1909, the industry has focused on enhancing the properties of fuel to address carbon deposits and to improve fuel consumption in the engine. Unlike fuel additives that only last as long as the fuel in the tank, the effects of NANOEFX applied into the air filter will last a minimum of 5,000 kilometers or 6 months, sometimes longer, depending upon the use case. The primary function of NANOEFX works indirectly in your engine. Rather than interfering with combustion, it acts by conditioning the intake air to be more volatile for improved combustion. It is therefore harmless and will not damage your engine. NANOEFX, an innovative patented solution, is the first product to approach the problem by conditioning the air entering the combustion chamber for ideal combustion. The result is a cleaner engine, more complete combustion process that uses less fuel, generates less emissions for a given power output. Simply apply NANOEFX uniformly to both sides of the air filter, allowing the active ingredients held as nanoparticles to impregnate. NANOEFX, revolutionizing fuel efficiency and emission reduction solutions. Join us in the movement for a better, more sustainable future.